No, let's go. And it's working. It is what it is. Okay. Now, guys, what we have here is question 2, okay? And what we're going to do is we're going to find this and check our solution. Okay, so we're going to integrate this and then we're going to see what happens when we're done. All right, so what we're going to do is we're going to use this formula here. Everybody see the formula underneath? Now we have to use the inlay technique. So is there any inverse functions? Any inverse functions? No. Any log functions? No. Any algebra functions? Yes. Algebra takes the u value. So u therefore equals x. Now we're after the v. What's the v, guys? The v is what's left over? Yeah. So it's e to 2x dx. Now, if u is x, that means du is actually dx. You're just replacing the letters. Okay, next part then. U times v. I don't know what v is yet, do I? But what can I do? Integrate. I'm going to integrate. V equals e to 2x divided by 2. Now I have all the information available to have a crack at the doing this. What's u? Anybody u? X. V. E to x over 2. Take away. What's v? E to 2x over 2. And what's du is dx. Now it's x ex over 2. And what happens when you integrate e to 2x? Huh? Oh, 2x, thank you. Thanks for that. Now, what happens when I integrate this? It stays the same, doesn't it? It's still e to 2x over 2. Differentiate the power, and an extra 2 on the bottom, which creates it as 4. And then plus what? C, and you're done. This question's a step up. So I've done question 2, and now I'm about to do question 4. And we're running the inlay system for integration. Is there any inverse functions? Like cos inverse, sine inverse? No. Is there any logs? No. Is there any algebra? Therefore, u is x. Du must be dx. And then what's left over is the v. This means the v must be the same as cos x dx. And therefore, v on its own must be, what happens when you integrate both sides? Sine x. Okay. Okay with that? Now we're not going to worry about the limits to the very end. Okay. So what we're saying is the integral of x cos x dx. Not. I can put the letters in if we want to, right? So what we're going to say about this uv. What's uv, guys? uv x sine x, and then minus v du. So what's v du, guys? Sine x dx, yeah. Then we're going to get x sine x. I'm going to integrate sine x minus cos, is it? It is, which makes a. Now, technically, there's a plus c there, but I'm not going to worry about that. I'm just going to wrap it in its brackets now. I'm going to put the pi over 4 and the 0 right here. Now, be careful with this because cos is live when x is 0. So it's going to be pi over 4, sine pi over 4. That's sine 45 degrees, isn't it? Which is 1 over root 2. Okay. Plus cos pi over 4, which is also 1 over root 2. take away, what are we taking away? Sine 0, which is just going to be a 0, but cos 0 is actually 1. So it's going to be pi over 4 root 2. Huh? So just give me a minute. Have I done anything wrong here? Oh, only multiplies for the first one, not the second one. Thank you. Sorry, guys. The pi only multiplies by the sine, not the cos. So the cos is still free as a 1 over root 2. Thank you. And then take away the 1 then, isn't it? And you could give it a common denominator if you want. You could put it in decimals if you want, but that's your answer, isn't it? Whatever way you want to work that. Okay, u is x, yeah? Du equals dx. The v is what, guys? dv is sine x dx. Okay. V is the integral of that then, isn't it? So I'm going to integrate sine x minus cos x. Okay. Okay, let's fill out our function then. So it's going to be the integral of pi over 2, 0, x sine x dx, and it equals u, which is x. V, so it's going to be minus x cos x. That's u times v, isn't it? Now minus the integral of v. Now minus v is a minus cos. Those two minuses interact with each other. And when those two minuses interact with each other, it become a plus, like so. And then du, which is dx. So what happens when we integrate cos x? What do we get? We get sine x, do we? And we get that for pi over 2 and 0. Okay. I might be inclined to use my table function here. And what I'll do with my table function is I'll go, what's it, home, table.
Why is it minus
Yeah. When if you integrate cos x, you're not getting minus sin x. Oh, do you? Oh, it was minus on the outside, wasn't it? Oh, sorry. If you reverse back a step, what happened there? I had a minus there, and my minus outside seemed to rub out, but the two minuses interacted to make a plus. So it was plus cos. You're integrating plus cos x. Yeah. And then when you integrate plus cos x, what do you get? Oh, plus sine x, is it?
Yeah.
My bad. Oh, good. And then we get that from what's pi over 2 and 0. If I was in the Leaving Cert exam, I'd be going to the table function right now, and I'd be doing what's the find function. And am I in radians? I am, and I'd be doing it like this: minus x cos x, and then plus sine x, and then I'd close it down like that. And what my two limits? 0 and pi over 2, isn't it? 0, and then where's the pi button on this again? Shift 7, and then divide that by 2. And there's my two limits. 1 take away 0, and I'm sorted. And the answer is 1. I think you got that ahead of me, didn't you? Yes. What we're going for first is we're going to go for inflates or inlate them in. And we're going to do a quick check amongst all our. Is there any inverse trigs? Is there any logs? Is there any algebra? If so, what algebra? So we're going to say u is x. And that means du also equals dx. You cool with that? And then it means that dv is e to the 3x dx. You cool with that? And then what else does that mean then? It means when we integrate them, what happens? Phi equals E3x all over 3. Okay, happy with that? Fill out our formula. The integral of x e to 3x dx uv x e to 3x all over 3 minus the integral of and we get the integral of e to 3x dx, right? So what we next get is, yeah, it was, wasn't it? Now there's going to be a plus c here, isn't there? Because there's no limits. Pause here. The v has a 3 on the bottom. That one? That's it there? Okay. Now, it's been a long day, gentlemen, long day. Now, what we get next is we're going to integrate this again, aren't we? And what happens when we integrate it? The power stays the same. That 3 goes straight in, but we differentiate the power, put another 3 underneath, and what's that? A 9. Okay, that's great. That's a 9. And then this stays the same, doesn't it? Now, and then there's a c at the end, isn't there? Now, I'm going to save this because this is a 2-part question. So I'm going to grab this and save it, okay, for later. So I'm going to group all that together. Go up top, shrink. Forgot my 9, didn't I? You can stay in there as well. Group. All right. We all good so far? Okay. Yeah, we're perfect. Now I'm going to save that for later. And now I'm going to go up to the next question. So I've successfully done part 1. And part 1 has this thing here. This yellow thing equals this yellow part here. And I'm happy enough with that. But however, I'm now attacking this green question. Okay, I'm gonna try and get this one done. Now, what does u change to? Okay, and du dx will still be just dx then. Just gonna doubly make sure that part actually. Yeah, I'm just checking that. So, do you remember earlier where we had u equals x? Yeah. And then what happens is you differentiate it, you're actually right, and you get du dx equals, I just have to remember this is the first time I've done this question, du dx is 1, and you're right, you cross multiply it up and you get du equals dx. For me, I was just replacing du with dx for those first couple of questions. However, because of the presence of the x squared, guess what happens instead? So you say u equals x squared, differentiate, and what you get? Du dx equals 2x. Therefore, du is actually 2x dx. So you're actually right, Alvin. There was a mathematical thing going on there. Just didn't matter for the first 7 because it was just x anyway, so it didn't really matter. But yeah, there was something mathematical going on there. Is that all right? So from now on, you technically are differentiating to get from step 1 to step 2. There was just missing steps in there that we didn't need till now. Okay. Now, what we're doing next, guys, is the following. Oh God. Now, so what am I asked for here again? What's u? X squared. What's the v? E to 3x dx. Yeah. And then what's u, guys? U is x squared. What's v? Anybody? V? It's the same as last one, isn't it? E3x over 3. What is, what's take away v? What's v? E3x, yeah? Over 3. And what's du? Anybody du? 2x dx, okay? Now here's the trick. See that 2? See this 2 here? If I was to take that out and plonk it on the outside, what happens to the whole thing then? What does it resemble? It's the same as the yellow one, isn't it? So everybody see the way it's the exact same as this one here is exactly the same as that one there. Therefore, I can sub the yellow part in there. Everybody see that? I can sub that yellow part in there. So what I'm saying is for this whole thing, this x squared e to 3x dx is the same as, what's that? X squared e3x over 3 minus 2 times that yellow part.
But it's not centric, it's e over 3.
What is it?
The red is just e, the blue is e over 3.
Oh, sorry, take out the 3 as well. Thank you. Take out the 3 as well. Does that sort the problem? Cool. Hopefully. As I said, lads, it's a long day. Now, it's very hard to be doing this stuff last thing in the day. And then the c value, you don't have to multiply the c value by 3. You just lob a new constant at the end. It doesn't affect anything, so don't worry about it. Don't worry about the constant of integration. It's always c. It doesn't matter. You can it just stands for a constant. You just know there's a random constant there somewhere. All right. Now, is there anything in common here? So what's this turn into? Yeah, we have a x squared e to 3x over 3. 2/3 of that, that'll be 2 over 9, is it? X e 3x. And then that'd be over 27 then, is it? Plus 2 e to 3x all over 27 plus c.